Ready? Okay. Good evening, everybody, and welcome to the December 13th Board of Selectmen, combination Board of Selectmen and Finance Committee meeting. It has one specific article, and that's it, and that's the infrastructure, water and sewer. So could everybody please stand for the Pledge of Allegiance? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Okay, opening comments. Mr. Taylor.
Thank you, Mr. Chairman. This, for the town out there, this is an informational meeting set up primarily by our chairman, wholeheartedly on infrastructure. Mr. Burrell and I have talked about infrastructure since September, October of last year. Instead of ball fields, instead of this, instead of that, the infrastructure really needs to be looked at. It's reached a point, and I won't say much more about it. Secondly, I'd like to really thank the DPW, and Dennis, thank you, and your people for the savings in water that I just checked with him, we'll realize that probably next year, but he's done a lot of work on water in town. Thank you, Dennis. Thank you, Mr. Burrell.
Okay. FinCom, any comments? No? No. Okay. All right. So we have Perry Manatee, Brendan Ward, who's the chairman, Judy Sahora, John Fulgham, and the infamous Mr. Clausen. Yes. I didn't recognize him with his beard, or John, but it looked good. We also have tonight Dan Coughlin and Dennis Ball from the DPW. Dan's our engineer that has done extensive work on the water and sewer since I can remember. So I'm actually going to turn it over to him because this plan's been in place for a couple of years now, since 2015, and I think long before that, if I'm not mistaken. Dan had worked on this. We are having some issues, everybody knows that, with water and sewer. We had three major breaks actually, on the Limway, which cost us $1.5 million. So I'm going to turn it over to him to give us the lowdown on what we should do and what we shouldn't do. Dennis?
I'll find a stand for that as well.
What do you need, Dennis?
I just said, we have a little show to tell.
Oh.
Thanks. Thank you, Mr. Chairman. Just want to just reintroduce myself. Dennis Ball, I'm your DPW Superintendent or Director, whichever word you'd like to use. I'd like to thank Dan for his time and effort tonight. Again, Dan Coughlin is the author of our capital improvement plan, which was put together in 2015, and it was modified or updated in March of 2017, just before our breaks. I'd also like to introduce Gail Lotus, also an engineer with Coughlin Engineering. She's a key staff member at Coughlin, and it has contributed to the development of that capital improvement plan, as well as the Force Main alternative package. Have you seen that plan yet? Have you seen that paperwork yet?
Yes. Yep.
Okay. So Dan has put together a package just for some talking points this evening. We're not going to get into the weeds or the minutia of this. It's purely an informational meeting. The numbers that you see were developed based upon facts that we know today, and obviously things can change the more that we get into the process. The capital plan, improvement plan specifically is a comprehensive document that illustrates the capital and operational maintenance issues, needs of the water and sewer system, and it was programmed over a 10-year period. That plan is available. It's available to the public if you want to get into more detail with it. Unfortunately, there have been several recent events that have accelerated the need to talk about the capital planning efforts. One, obviously, is the sewer breaks that happened, that occurred this past spring. It was very, very costly to the town. You know, municipalities, we all count our budgets in pennies.
Thank you.
So those three events cost us a true, in hard dollars, almost $1.5 million. We had to go out for a borrowing to pay the contractors. It's something that we can't sustain over and over again. So those issues, mechanical problems, and the continued deterioration of our main pump station, which is down in the lowlands, and just system-wide issues that are decreasing the reliability of the system to convey a flow. Another issue that we've run into, and it's based upon a cable TV, or excuse me, a videoing program that Dan had put together in 3 phases, and we were actually putting cameras down into the sewer pipes to see what the conditions were. There are increasing levels of what we call I&I, infiltration and inflow to those systems. We're probably 3/4 of the way through phase 1, which was the Willow Road area, Nahant Road towards the harbor was cambered. So we have another third or a quarter to still do. It's a matter of, we're talking about money at this point, how to do that. We had some tremendous obstacles that we ran into that prohibited us from getting our camera equipment into the pipes. Okay. Pipes, rocks, crushed pipe, laterals that you know people threw together, and again, offset joints. The pipes now go like this, and they're not true. Older material that has seen its useful life. All right, so it's time to you know, pull things out. On the water side, well, actually on the sewer side as well, the force main, there's evident deterioration and aging of that pipe. The pipe that we had problems with was installed in 1978. Yes?
For those of us that don't know, what is a force main?
It's the pipe that carries our wastewater.
So the main.
It's the main pipe, and it's under pressure. It's under pressure, and that's how it gets to the end point in Lynn. It has to be pushed. All right? It's pushed under pressure.
It has to be pushed basically where, from lowlands over the hill where the tides is. Once it gets past there, it's gravity. It's not.
No, it's pushed
It
all the way.
is pushed, but it could be gravity if it was low enough. I mean, Swampscott's all gravity.
Schwab's gets a force main.
They have a force main, but it's gravity on the I believe on the
Okay.
on Winshore Drive. So the force main is very important.
It is. It's a pipe under pressure, all right? And it has to sustain the pressure in order to get the effluent from point A to point B, point B being the Lynn Water and Sewer Treatment Facility.
You said
Right.
that was installed in 1978.
78. Well, we're almost 40 years into it at this point. 60 years, possibly?
Yeah, 50 to 60 years is what you typically estimate for the life of that type of pipe. However, if there's other things that are affecting it, corrosion, you know, tidal fluctuations, there's a bunch of different things that can basically degrade the pipe circuit.
So where we're at a disadvantage right now is the depth of our pipe. Our pipe is at 12'5" to the top of the pipe. So and it's an 18-inch force main ductile iron. Mm-hmm. It's a ductile iron pipe. It's subject to tidal. It's in you know, salt water. It's in salt water. So that obviously we know what the science is on that. All right, so that's a challenge we have to deal with. But on that pipe, which is also driving this, there are components that help that pipe operate. One of those components are air relief valves. All right, to get the hydrogen out of that pipe. Sulfide, excuse me, will deteriorate the interior of that pipe. So I have 4 to 6 of those relief valves that are not functioning. All right, I've looked into that. We've priced it. We've engineered it. We're still debating whether or not how we're going to approach that. all right, but those are some simple solutions that we need to do. We've done some work on the front end of the system. We changed the timing of the mechanics, how we push it, how fast we push it, to try to soften the pressure a little bit, to simplify the conversation. So we're working on that. Yes, yeah, so effectively, what's that, ma'am? Yeah, yes, but, in the perfect world, all right, in a perfect world, but, you know, though it's subject to ambient air, which is we're in the Atlantic Ocean, these devices effectively just rotted off and fell off its connection.
Can I just point one thing out?
Sure.
When we had that break last April, they had to work with the tides. Where that break was on the Limway, when the ocean came in, that was filling up with salt water.
I certainly don't know, but I thought that that time that the story was, that part of that break was because of construction was being done on the Linway?
No, it's two separate issues. Two separate issues.
But it just shows you that, you know, any kind of metal pipe is subject to salt water, it's gonna, you know,
Although you need to, I guess I would have understood it 40 years ago when they put it in, they knew that you could hit salt water. So that supply,
Right.
was built for salt water.
but that's what they used 40 years ago, that's all they had. They didn't use, I don't think they could use plastic 40 years ago.
No, we didn't have that, the technology wasn't what it is now. But moving forward on the water aspect, and thank you, the citizens, for your patience last, what was it, Wednesday, Thursday, we had a water break at 5 o'clock in the morning. My crew, I want to thank my crew. We did extraordinary work to get that system back up and running within an hour. And yes, there was some inconvenience, but thank God we live in America, okay? So anyways, numerous water breaks have started to occur. That pipe that broke on Nahant Road last week, that elevation, top of pipe from the street is 3.5 feet, all right, and it's in water, all right? There were some photographs that were circulated via Facebook. People that had an understanding of what that pipe actually looked like. We had a vertical break, right?
Yeah.
Yeah, we had a horizontal break on it, and if you look at the pipe closely, you can actually see where the demarcation, where it's actually sitting in water most of the time. It's all pitted, it's delaminated, et cetera. So we may have a problem with that. It's very, very costly every time we have a water break in town, particularly on the larger pipes, right? Where we don't have the capability to self-perform, depending upon how large it is. It costs us an average about $1,100 an hour, all right, to fix a pipe, all right? And again, we can self-perform as a DPW, we can do a lot of things, but when it gets into the 16s and the 18s, that size pipe, we bring in outside help, and again, it's very costly. And again, the deteriorating infrastructure is due to age, wear, corrosion, limited maintenance, and just its useful life at this point. So we have a lot in front of us. We have an idea of how we'd like to go, though that thing is going to be very fluid. It will change. It will change based upon what we actually find once we get into some investigation. And Dan will drive that train. It will change based upon the finances, what's available to us, both locally, federally, and state. My belief, I may be wrong, but because it's a critical infrastructure, I think some of this money can be obtained from the federal government. And we have some nice partners. We have some good partners with the Inland Water Sewer Commission, and they can help us, through that process. So that being said, in front of you, we put together some talking points. Dan will go through that document. I would try to like to stay away from the minutia of it. If you have questions, absolutely ask Dan. He's the subject matter expert. He is our town engineer. Spent a lot of time developing the capital plan. It's very comprehensive. It's very, very comprehensive. It should be a living document at this point, moving forward. So Dan, if you want to jump in?
That book used to be this big, now it's been short.
Why don't you sit more comfortably here?
Good evening. Dan Coughlin, Coughlin Environmental. Gail Lawless, PE with our firm. She's a geotech, but also does several other things, so she's here tonight as well. Does a lot of work in Nahant. As Dennis said, I think he gave a nice overview as far as what's been happening more recently. I think what we need to do, though, is go back to the original capital plan that we had. It's basically this document here. It was originally produced in 2015. We were able to do some TV work on the sewer system and find kind of a level of defect that was in the system. And at that point in time, we also updated it again this past March to try to bring that up, incorporate those other revisions or defects that we saw. Obviously, we've had a lot of force main breaks along the Linway. That is not involved in the March issue, but it's evolved over the past year or so. And there are a lot of concerns regarding that and additional costs associated with we're trying to rectify that or create a system that's more reliable overall. I did give you a little handout, and it just kind of gives you a broad sense of some of the things we've been discussing. As on page 2, Dennis outlined that we've had 3 major force main breaks on the Linway in the last 2 years, a significant amount of cost. The indications of those breaks indicate that there's a lot going on relative to exterior corrosion of the pipe, corrosion via fluctuating brackish waters or groundwater tables, that's tidal, as well as soils, corrosive soils. There's also evidence of cathodic issues with the pipe. In other words, what we're getting is basically some delaminating of the pipe because of stray electrical currents. And that could be related to a lot of different things. It could be related to the extensive electrical lines that crisscross across the Linway. There's also electrical rectifying equipment to fight corrosion on the gas main that could be influencing some of that as well. But the bottom line is there's a lot of unknowns. It's not your typical failures that we're seeing on the Linway. These are advanced failures. Obviously we said it was in the range of 50 to 60 years, and now we're getting 3 failures in a short period of time. We don't know how many more we will have in that area. If we had 3 in a row, I would suspect there's more areas that are probably weak and probably need addressing. And the question then becomes is how do we assess those, how do we evaluate those, and what solutions do we provide to try to provide a reliable way to convey the wastewater from the town to the Lynn treatment plant. In addition, I think Dennis also mentioned the Lowlands Pumping Station, just as old as the pipeline. It's been upgraded kind of piecemeal over the years. It needs a lot of work. The wet well area has a lot of corrosion. Scaffolding or support systems, walkways in that area are basically unreliable and unsafe. Ventilation is an issue at the station. Recently had the commuter or channel grinder fail, and there's a lot of other little issues on that pumping station. It's in need of some major upgrades, and those are still being, for the most part, evaluated. Weston and Sampson did provide a report back in '95, which evaluated all the pumping stations, and that was recently updated, or just a 4 or 5 page summary of the defects at the other stations were all summarized this past January. The total amount that they estimated for kind of immediate repairs was about $280,000. Now, I would suspect that number, in order to bring the stations back to a very reliable position, would be significantly more, but that the stations still be evaluated. Dennis did talk about the II, which is infiltration and inflow. This is extraneous flow entering the sewer system. DEP recently came out with new regulations they implemented this year. And basically, they're forcing every community within the Commonwealth to do, in essence, what they call a sewer system evaluation survey. That typically includes flow monitoring, other elements to try to identify II sources in the system to reduce those flows in order to provide less stresses on the treatment plants and thus less overflow instances within the communities. We still have overflow conditions that occur at the Lynn treatment plant during wet weather events. Those are controlled, though. And in terms of the town's II, as Dennis mentioned, we have a lot of defects in the sewer system. We actually initiated the TV inspection program, which is a good first step in the evaluation of the system, because the TV inspections give you a clear depiction of what the defect is, and also at the same time allow you to make a good judgment as far as how to correct that defect. However, as you mentioned, there was a lot of debris in the system, a lot of offset joints, collapsed pipes, broken pipes, protruding services that have basically made the system very difficult to evaluate. And it will be a process, but the town is proceeding with that type of evaluation to identify those problems and correct them. In terms of the sewer, there have also been other issues over the years, some blockages, collapsed pipes, and those have taken their toll and also appear to be influencing some of the other equipment downstream, like the pumping stations. The channel grinder at Lowlands seem to be have advanced degradation, primarily due to gravels, grit, rocks that make their way down the pipe as part of it. And then you also have to beg the question, where all the rocks and grit and everything else come from? And typically that's from collapsed pipes or areas that are open that allow soils to enter the system. In terms of the pipelines in the town, Dennis mentioned about the valving on the system. The pipes are getting fairly old. The force main for the lowlands is the primary and only mechanism the town has to get rid of its wastewater. There is no redundant pipelines. There's nothing else. When we had the breaks and the stations couldn't no longer pump, basically all the flow was being hauled, pumped and hauled, by truck until that system was rectified. So it's not an ideal situation to have a pipeline that has some questions relative to its reliability. We also, in the capital plan, we also evaluated the water facilities. It seems the water facilities, have seen a little bit more attention over the years than the sewer system, so they weren't in that bad of a shape. There were numerous breaks that occurred, and a lot of those were related to aging pipes. As Dennis mentioned, the last break, there was a lot of exterior corrosion. The pipe was fairly shallow, so it was also in the frost line, which put it under additional stresses, and basically the pipe failed. And that type of situation more than likely exists in many other areas within the town where you have tidal issues or corrosive soils. So it's something that basically that needs to be really assessed and evaluated. Normal wear, age, corrosion, and there's also certain aspects regarding the maintenance and exercising of the system, which unfortunately over the years have seen less and less fulfillment of what was planned for them. There's a valve exercising program that you can go out and exercise the valves to make sure they're functional and working. And when you have a break, you go to those valves and you're able to close them and isolate them. So that program has kind of been shifted a little bit and never actually gets done on a regular basis. Same thing goes with some of the regular maintenance on some of the hydrants and other components within the system. So for the most part, the system, if it doesn't get those types of maintenance activities, will tend to degrade, become a little unreliable. And like I said, when you have a break and you go to turn a valve and it doesn't close the system, creates more problems for you in the long run. One of the things that we wanted to talk about too tonight is where we've been from a planning perspective. I think I mentioned Weston and Sampson put together a plan back in '95, which is quite old at this point in time, regarding the pumping stations and their conditions.
Just, who's Weston and Sampson?
Okay, sure. Weston and Sampson basically does the operations for the wastewater facilities. So in terms of running the pumping stations, maintaining the pumping stations to some degree, keeping them operational, addressing alarms, Weston Sampson is currently a contract operator to run those facilities. They've been with the facilities for some time. Like I said, back in '95, they put together a plan for repairs at the various stations. Basically, this was the document here. And then more recently, they've tried to update exactly what needs to be done at those individual stations. And they came up basically with a shopping list as well for those stations.
I believe they made them all wet wells, didn't they?
Yes,
Those stations.
most of the stations are.
Some work was done.
Yep. A lot of the work converting some of the dry wells to actual wet wells to create more volume in there for the pumps. But there was a lot of different conversions, but there's still some significant work that needs to be done at these stations. In terms of monitoring flows, when we did our '95 report, there were many studies that we did to evaluate the system because nothing really had been done to evaluate the system prior. We looked at the...
95 or 2000?
I'm sorry, 2015, sorry. In 2015, basically, we looked at all the flow data for all the pumping stations. We analyzed that data. We were able to detect at that point in time there was significant II in the system, which is the infiltration inflow. And what that does is when you have extraneous flows like that in the system, it makes your pumps work longer, work harder. It makes the peak flows even higher than what they normally should be. And basically, you're still paying for all that flow as well, going to the treatment plant for treatment. So the more you can do to eliminate that and exclude that from the system, the more reliable your system is and the longer lasting your system is. So II really robs you of a lot of your capacity, a lot of the useful life of the system. And that's why it's important to identify that.
So just, pardon me. Sure. So for a quick example, well, this is a simple example. Our normal flow on a wastewater day is probably 500,000 gallons a day. If I have a heavy rainstorm or an extraneous heavy weather event, that 500,000 goes to 1,500,000.
$1.5 million.
5 gallons per day, right? So that's the delta. We pay for that delta. All right, on the other end. So just as a quick.
We as the town,
Yeah.
Absolutely.
That's just all
but
water.
not the water, that wouldn't, because we're in a water and sewer enterprise fund, that wouldn't be billed to the end user that comes out of the town side? How does that get billed?
Well, it comes out of the enterprise. Out of the enterprise.
Which is
So it's built into the user rate?
It would, yes, yes,
pretty well depleted.
yes, yes.
Right.
Just as an example, I'm sorry for Dan.
No, that's fine.
Question about that, then, if the average flow is 500,000 gallons, is that what you said?
Yep, per day.
And then because of this, somewhere along the line where you saw the average flow was going up,
Right.
why wasn't it addressed at that point? So you understand what I'm saying? It's not.
But it's not an everyday event. It's not an everyday event, all right? It's very, very difficult to
We're talking a max day period.
How often does that max hit? How often does it, and how long has it been going on that max got larger? I'm just trying to
Okay.
understand the pattern.
Just to give you a little, yeah, just,
Why today, why now? Why not 2 years ago when they did that, when they redid it again? Is it a brand new problem, or is it something that's been going on?
no, it's something that's been slowly creeping on you.
creeping up.
I guess what I'm trying to figure out, why wasn't it addressed when the issue was first?
Tough
It no
question.
longer matters because it's here and it has to be fixed.
Does have to be fixed.
All right, but again,
And it's a money issue. I mean, it has to be, that was the purpose of having this meeting tonight, so everybody can get an idea what we're up against. And people have to understand, nobody wants to spend money on it, but we have to. And now's the time.
Yeah, in terms of identification of it, you know, you can see it on the flow meters going to the LIN
treatment plant, but internally within the town, your individual pump stations do not have flow meters, at least most of them don't. That's something that, would help in some cases to identify the level of flow. What they have is basically just runtime. In other words, how long do the pumps run? And so someone has to really look at that data, evaluate that data, and generate something, look at some of the rainfall events, look at those periods of wet weather, look at the periods of high groundwater, and evaluate it to come up with, where the source of the problem is. You have the problem, but the question is where it is.
I think the analysis was, there was a time period where there was multiple issues of turnover as department heads at both the DPW and the
Right.
town administrator, and I don't know that to answer your question, I don't think that anybody was doing the analysis of this particular problem when there were other problems that were being focused on.
And the other thing is, a lot of that has been taken care of, the pump run times, and that's the easiest way to find out if you're wasting water. Or, you're pumping, those pumps keep running all the time. Dennis has actually solved a lot of that. There was a water break on Mayolis Road that was just going right into the sewer station. Yeah, there was, yes, and it just kept pumping and pumping and pumping, and we picked up on it, and he had it repaired. All that water was just going into the sewer, and you don't know that it's going into the sewer because you just... Right, you can't... And then there was another one on Carey Street, right?
Carry away, yeah.
Carry Way, yeah. So those are two things that he's tightened up so far, and I think, looking at the MWRA reports, it's gone down quite a bit. But you're always going to have water infiltration into the sewer system because of tightness,
I understand, I understand the concept. I'm just trying to get a little bit of history of why we solved the problem, as a town, solved the problems going on. Why now, why today, why not 5 years ago, not 60 years ago, 10 years, when the issue started to arise, so it didn't become such a...
Can't speak.
It's not as a history of
No, can't speak to that.
Right.
maintenance and waiting for a catastrophic event.
So is there a way to monetize the size of that problem? How much is it costing us for the excess flow that we're pumping? How much, what are the ratepayers bearing?
Yeah,
I think that's a discussion for another day, because it's too in the weeds, but yes, we could put a number to that.
Yeah.
you could derive
We could derive a number,
something that's close.
At best, like that.
right.
Well, if it's 1 million gallons, then,
But you know the average flow.
right.
Correct.
Right.
And even for the most part, the average flow represents a certain amount of extraneous flow in it.
There's no way to know.
There must be an acceptable...
There is. Basically, what you do is you look at the dry weather periods. Excuse me. So if you look at the dry weather periods, when you don't have a lot of wet weather, the groundwater is lower in the summertime, you can get a baseline flow, and you can use that to extrapolate how far off you are.
The statistics for, let me say this delicately, how much an average ratepayer produces per day?
You can do that as well.
Yeah.
Yep.
Didn't we have that done?
Yeah, well, we did some of that evaluation in here as well. It's just the specific number as far as what the dollar value is or the impact is wasn't specifically addressed.
Some of it could be drainage issues too, I think, infiltration, because, I've looked in the wet well, I've been down there, and I've seen logs, rope, you name it, going through there, and that,
Yeah.
yes,
Hard to tell where it comes from.
How that gets in there.
The follow-up question to that is it reasonable to assume that if we proceed with some of this stuff, we should see those costs go down as we eliminate the INI?
Correct.
Yes.
Yeah.
And that's really the state's emphasis too, with their new regulations, trying to force all communities to do this. Because some communities have a regular program. Some communities, more like Nahant, try to address it, when they have the manpower and dollars to do that. And some communities don't do anything. So the state's basically mandating that all the communities do this type of evaluation, yeah.
And as we move forward, if and when we do some of this work, will there be the capacity to have some sort of monitoring of that so that we can do this analysis and keep track of when we're losing through I&I and when we're losing water through unknown breaks.
Yeah, steps have already started to be taken in there. All the stations now are on a mission system, which is the communication system that records them automatically, the run times. Those programs can also be set up, and we have plans to do that, basically set them up to put a typical flow value in there so we can actually quantify the flow output from each of the stations, which is a different issue too. Every pump can put out different flow. You know, they wear down, they have different issues, so it's not like a pump will continually put out the same amount of flow. So periodically, you also need to look at those pumps, do drawdowns, in other words, calculate how much flow it's putting out at a given time, and incorporate that data back into your model so that you have a good representation of what's going on for the flows. But the pieces are in place at this point.
Ultimately, the measure is what water and sewer is metered as it comes out.
True. And the calibration of their meters is also a concern, obviously, for billing purposes. And it's always good to have a good correlation between your numbers and theirs.
Yeah, so
And
we have done that to the extent.
it's been looked at. We do have a flow meter at the lowlands, which is the main pumping station heading out of the town. So that flow meter should correlate very well with what Lynn Water and Sewer is measuring. No two flow meters are going to measure the same flow, different kinetics of the configuration of the piping and, you know, as the flow passes. So that there's a lot of things in play there, but they should be fairly close. Sometimes they are. Sometimes they're not.
What's an acceptable,
You like to see them within 5%. That would be ideal. 10%, you probably will have those variances every once in a while. Beyond that is more significant, and there's something that needs to be corrected or calibrated again.
And when you get to that beyond that, whatever threshold is set, is that then addressed, or is it not that point?
Well, I mean, that type of monitoring has been going on for a long time, and I believe when the differences occur, they'd first check with Lynn Water to make sure that their calibrations are in place. They'd calibrate their own meters and basically try to make sure they reconcile. And I think that process in itself has helped to correct or keep them close. The question is how often the meters are calibrated, and I believe that's now on a kind of a regimen at this point in time. So, should be better. Okay, in terms of, you know, some of the dollar values, and that's really what we had to talk about is some of the numbers that we have in here. One of the things, too, I should mention, too, is after we had a couple of breaks this past year and a half or so, the Selectmen also asked us to do an evaluation of alternatives for the force main itself. So this report which was put out in this past November, was put together, and basically what it did is it evaluated alternatives to creating a more reliable system for the lowlands force main. And that evaluation yielded a couple different results. I'll talk about those a little bit in here, but what it really this was a basis for also a grant application as well, to try to get additional funds to do further evaluations on some of these alternatives. Just to discuss that quickly, I mean, looking at your pipeline, there are ways to evaluate your pipeline. They're very expensive, and it can be problematic at the same time because this is your only pipeline with conveying the flow. Some of these methods involve actual access to the pipeline, putting probes and other things within the pipeline to measure the wall thickness of the pipe as a probe passes through the system. Other methods include having to actually do excavations and dig up the pipe to contact it. But all of those are fairly disruptive and fairly costly, but they are options to evaluate that pipeline. It's been our feeling that the majority of the breaks have been on the Linway. The Linway seems to be the most congested relative to utilities and electrical equipment, and that is probably your highest priority as far as evaluation of the system, and potentially your highest priority relative to alternatives for that pipeline. So some of the things we looked at was the repair of that pipeline, the evaluation of the pipeline and repair of that pipeline, slip lining the pipeline, putting in liners in the pipeline to make it stronger or increase the integrity. And we also looked at other alternates, which is basically the cross harbor pipeline, the directional drill from one end to the other. And all those alternatives were assessed relative to cost, and actually the cross harbor pipeline, which would then give you a new pipeline going across the harbor, was really deemed to be the most attractive relative, not only to cost, but also long-term use. Trying to go in the Linway, as you know, we have almost 41,000 vehicles per day traveling that roadway. It's very difficult to do construction work. It's very difficult and expensive to do construction work. The pipeline in the Linway navigates through, up and down, underneath culverts and other utilities along that, so it's not a straight shot. Makes it very difficult to upgrade. You can't do slip lining. Cure and place liners would only be done in segments as you go along. You'd have to actually do some physical alterations of the pipeline as well. So it becomes a very expensive operation to try to rehab that pipeline. And it's even worse now than it was when it was first constructed, because there are probably 3 times more utilities in that area than there ever were before. So in terms of trying to place a new pipeline alongside of it, that may not even be feasible in some of these areas. So it's very difficult to do in the Linway. And with all those unknowns and additional costs involved, the Cross Bay pipeline appeared to be the best mode for replacement of that.
So, when it gets the picture, this is on the Lynn side, not the Swampscott side, it's gonna go.
Correct. Yeah, Gail, you have a,
It's a marina.
Right.
sure.
We have pictures.
Yeah, we do. So basically, this is the causeway in here. And the ball field is at the end near the rotary. And what we're doing is basically, we'd be going in here and going across, and then the treatment plant's right up in here. So it's basically going directly across.
It looks like, if you look at the aerial picture of it, Dan, it looks
Yep.
like it's deeper there. Is that why you did that?
Well, you have your navigational channel in here.
Right.
And you also have another channel that's over in this area. Basically, you have to get underneath those. And you have to get underneath those deep enough so that your borehole doesn't blow out as well. So if you want to just flip it over, just real,
So this is on the Lynn side of the harbor, not
correct,
on the side. So we continue to go under the causeway, and then at some point on the other end of the causeway,
correct.
go across.
Take a left here.
Right near the bathrooms there, across the street.
So that corner won't cause a problem.
No, it's the other end.
No. You're talking about the
other end.
bends in the system? No. Yeah, it's really not that bad. You can easily put in 45s. You don't put in 90s. But 45-degree bends is fine. You have plenty of those along the existing pipeline route as well, trying to go underneath and over utilities. But this is primarily the route, and then this other pipe here, which is still the existing force main, basically, you could upgrade that by putting in a new pipeline next to it. There's plenty of room in that general area. It's not as congested as the Linway, so theoretically, you could replace this pipeline too. But I don't really feel that, at this point in time, this pipeline doesn't exhibit the same degradation or level of degradation as the other, but it's still old. It's got, it's approaching the effective, useful life of the pipeline, so at some point in time, you have to consider that.
And that's not an environmental problem for
No,
There's a permitting process.
yeah,
That's on the causeway. Is it on the, it's on,
No, across the harbor.
across the harbor. Yeah, I mean, with a directional drill, it actually is less of an issue, because you're not disturbing, bottom organic organisms or interrupting fish or disrupting anything along that line. It's just a directional drill completely across the harbor. So that was one option that we looked at, and it seemed to be the most effective on just so you get an idea. This is the navigational channel, the cores channel, and this is some of the other channels. So basically, this is exaggerated because of a split scale, but this goes down about 18 degrees at an angle, goes underneath and comes back up about 10 degrees at an angle. And once the directional drill goes in, the pipeline is then pulled back through that borehole. And what we're looking at is basically an HDPE pipe, so it's a high-density polyethylene pipe, and its life expectancy is significant. You know, considered to be over 100 years. Smooth lined, no, you know, everything is butt welded for the most part, so everything provides good hydraulics and basically is not subject to degradation over a period. Thank you.
There's a rock ledge that goes across from Nahant to Revere, I think it is. And is that going to be in the way of this project or not?
We looked at some of the existing boring information we had there, and it's hard to say. You know, part of the design and evaluation
The
process,
reason I mention that
I mean, it can go through rock.
they were going to deepen the harbor entrance in the Lynn during the war.
Yep,
And it was so expensive, they threw it out.
okay, because of the rock removal?
Yes.
Yeah.
So I don't know if you're going to run into that problem or not, but that's something that you
Yeah.
should be aware of.
Yeah, I mean, it slows the process down, so it takes a little longer to go through rock.
Yeah.
But the more difficult thing for these directional drills tends to be the softer material, because then they can't guide the drill where they want it. There's no sidewall tension or sufficient sidewall tension to allow that to happen. So doing a rock core would be fine, it'd just take a little longer. As far as we know right now, we have a lot of soft sediments on both sides. We'd have to do borings along the route to try to get an idea, a better idea for the contractor. But even if it's rock, it wouldn't be an issue.
What kind of permitting do you have to, is it a monthly,
Yeah, it's fairly extensive. You'd be probably talking 6 months to a year. The whole process, you're probably talking 3.5 years, so it's a period of time down to 4 years, you know. One of the things that we looked at as far as more immediate help on this, in case we did have more breaks, was also trying to do a connection between your existing pipeline, kind of near the rotary, and the Swampscott pipeline. And given an emergency condition, it would be feasible basically for both pump stations to utilize that force main for a short period of time. Swampscott's, you know, was willing to listen to it and evaluate it, and when the grant was put in, we, you know, part of the grant application that we did was to look at it from a regional perspective. Because also, same way that we could use their pipeline, if their pipeline ever broke, they could use our pipeline. You know, it would be designed such that you could have flow in both directions. So that's another option that we looked at, and if you did do that interconnection, you know, now or as quickly as possible, it would provide you some relief. If you had another break on the Lindway, you could basically shut a couple of valves and still be in operation without having to pump and haul all the wastewater from the town. Given that's,
When we had the 3 force main breaks that equaled about $1.5 million, well, to break down those costs, I think someone had mentioned that it was somewhere around $150,000 a day to truck out the sewerage. I mean, do you have any understanding of what the cost was for the actual labor and parts versus what it was to keep the sewer system running? So to give us some understanding of why this is important.
Well, for an example, the vacuum trucks. One vacuum truck was $350 an hour. All right, I had 10 vacuum trucks on site, 24 hours a day for almost 7 days. So that was almost, that number exceeded $500,000.
600,000, I think, that bill.
Well, it was full,
Just in moving sewer.
and just moving affluent.
In one break or all break?
that was the one major break.
That was the one major.
In one break. And the estimate that you've given for tapping into the Swampscott is about 700,000.
Correct.
So, I mean, it almost paid for itself with just one breaks trucking of sewage.
Correct.
That 700,000 is built for interconnection. Is there anything else that has to be built to make that interconnection happen?
We'd have to do some evaluation of the pump control systems at each station to make sure that we weren't battling each other relative to flow conveyance. And there'd have to be some type of agreement, obviously, during those emergency conditions to run the stations in a certain fashion. So there'd have to be some evaluation there as well. But basically, it's basically the physical pipeline, which is the major cost here.
That's for us to hook up to their sewer.
Correct.
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 Another, the community compact grant is for.
It's basically for
having them-
regionalization, including that, but also looking at that cross-bay pipeline so that we can evaluate that to a greater degree,
And
in other words.
they would tap into ours as an emergency.
Right, on an emergency base, if they had problems, that same pipeline between the two could be utilized to convey their flow to ours. And there are some limitations, relative to the pipe size that we can do for the directional drill, velocities we use, so even under that scenario, there'd have to be some agreements relative to how the plants, or how the pump stations operate.
Face a similar set of issues regarding the condition, location of their pipeline?
No, they're actually in a little bit better position. Their pipeline kind of traverses around the Linway. It goes uphill and goes around and then ties in, and it's on the roadway for a short period, but for the most part is off the major route. Their pipeline hasn't had any breaks. It's newer, obviously. So, I mean, for the most part, there is no driving force for them, but it's always good to have an alternate.
Do they have excess capacity?
In their pipeline? It really all depends what they're flowing at for the pumping station. Their pumps can basically utilize the entire capacity for the system. And during peak flow events, intense wet weather events, they do use a lot of flow. And that is the only limitation here is, they put out, 4 to 5 times, on a max day base, what Nahant would put out. So when they're using that under max day conditions, there isn't much capacity left in their pipeline. But again, breaks happen not necessarily on the max days. Those max days only happen a couple of days a year. So generally speaking, you do have an opportunity to use that pipeline on a break and utilize it effectively.
There would have to be some negotiations and an agreement.
Correct.
Formal agreement in place as to
Right,
when, where, how much, what note.
obviously. Right. A lot of institutional requirements.
So based on how far along this number is in a presentation to us, I'm assuming that some conversations have begun.
Oh, yes.
An out in left field idea, this is
Right.
close to, if we wanted to do it, it
Yep.
could be done.
We've had table talks.
And again, the grant application was with both communities on this regional base, so. It comes down to, further evaluation, what the numbers are and how it works.
And then should we proceed with the cross-bay,
Russ Harbor, sure, yeah.
would that give us additional capacity?
Um,
And then, the follow-up question is sufficient capacity to handle both Swampscott and Nahant, should that event occur?
Yeah, if, we have 2 options for that pipeline. We have one, which is basically installing a 24-inch HDPE pipe. Now, the 24-inch HDPE pipe is essentially the same capacity as your 18-inch now. A lot thicker wall thickness, so the interior dimensions are smaller, but it has better hydraulic conditions, so it conveys the same flow. To allow even more capacity in that pipeline, we could go to a 30-inch, and with a 30-inch pipe, we would have more capacity for Swampscott to use. So the question becomes is, when you get to that point, what size pipe do you put in? And the question is, does Swampscott want to participate?
Yeah, we want to co-invest.
Right. Because there is a significant cost increase associated with a 24 to a 30.
Do we have any understanding the population in Nahant decreases. I'm sure if we were looking at the demographics from 40 years ago versus today, there are less people that are living here per household. Does that add into the flow in terms of less people creating less waste to flow through the pipes?
Yeah, hopefully the case. Hopefully a lot of conservation measures, you get water-saving toilets and shower heads. You got II programs now mandated by DEP. All these factors should help to, reduce the flow. So ultimately, the capacities on those pipelines, instead of being marginal with both communities in, might become something that is, well-designed and feasible under those conditions.
What about the force main on Willow Road?
Basically what we have is, we also have another older force main within the community, and that's an AC pipe, and that's asbestos cement. It's similar to a concrete pipe, very thin wall though, and it has basically a tendency for shearing and cracking. And any type of differential settlement, changing groundwater conditions can influence that and cause that pipe to fail. It's fairly old at this point in time. I don't recall the actual date of construction, but it's basically near the end of its useful life as well. So that is a potential issue that we have in the system that, is basically a problem waiting to happen. So we have looked at that station as well, and one of the line items we had in there was basically $840,000 for the replacement of that pipeline. And that would probably be with a similar type HDPE pipe to be utilized there as well, to extend the useful life.
I think that's something we should probably look at now. That's really old.
Yeah, Dan, looking at this number is certainly overwhelming just on the wastewater side.
Sure.
Is there a way to implement this, I'm assuming in stages, so that we're not, for instance, spending the full amount in the first 3 years or the first year? I mean,
Yep.
do we have a plan in place to sort of
Yeah.
incorporate this?
Originally in our capital plan, we had this table here, and it has basically date-specific implementations.
Yeah.
10-year program.
Yeah, we had a 10-year program. Now, not everything for 2016 was conducted in 2016. So, I mean, there is a little slide here already with the schedule.
And a lot of the stuff on here is not, a lot of the stuff in the presentation is not on the schedule.
Right. Basically, everything on the color version of this, we have is having the brown color, is additive to this. This table here. Correct. Correct.
What's the significance of the plus signs and the double asterisks?
Double asterisk is basically a priority item. So, in terms of if that pipe were in place, it would pay for itself probably in one break. If you can get that in place, it provides you some relief as far as incurring additional costs down the road. So we look at that as a priority. Same thing goes for wharf. That's an old pipe. It's subject to failure. It'd be nice to get that done relatively soon. The plus sign, this is for sewer system repairs. And as we mentioned, we were doing some closed-circuit television, CCTV inspection of the sewer lines. And we did some of that already. We basically broke it up into 3 phases. We're about 3/4 of the way or 2/3 of the way through phase 1. We're trying to finish phase 1, but we had some difficulties with access to the pipes. But those videos basically reveal the defects in the system, and based upon those, we just so you don't get sticker shock here, we looked at the 3 phases, and phase 1 is the highest priority areas, the ones that we think we would have the most problems in. So obviously, we're going to find the most problems in them. So right now, just with 2/3 of the way through Phase 1. We estimate close to $1.5 million of work, as far as repairs to the system that would need to be done. And I put 3.3 plus because we've only gone so far into a multi-year program, and we're going to find more. Similar to the pump station repairs, we have a plus sign on that. We have that's 280,000 was kind of the minimum criteria at those pumping stations. But, if you went and visited the stations, there's other aspects that need to be.
The plus sign is sort of an educated guess,
We know it's probably going to go a little higher.
where the others
Yeah.
have some sort of estimate.
So Dan, is this just for the water side, this capital improvement plan?
All the blue is water.
Yeah.
The brown is for sewer. And there's a green down the bottom, which was drainage system. I'm sorry?
Did you choose those colors on purpose?
I do usually, yes.
Good choice.
Makes it easy to find them. So, again, on,
I'm sorry, one
oh, go ahead.
The older numbers, I'm assuming have not been updated. There appears to
Correct.
be some differences between the handout tonight and the capital plan.
Slightly.
Even on the,
Between these two documents, yes. Yep. Slight differences, yep.
I just want to mention that Deb Waters, who is our financial guru, couldn't be here tonight, and she has actually showed us, and it's very confusing, but she showed us how much we can borrow. And this would all have to be done through borrowing, obviously. I'm sorry?
Right. we
Oh,
don't-
yeah,
right.
well, we look for grants, obviously, but mostly it would be borrowing. We'd be borrowing the money.
What's the anticipated amount that's available to children?
Through grants? We don't know, that's,
There's a funding page here.
right.
Dan included it.
Yep. At the very end. if you
Funding
wanna-
options, next to last
We
page.
can talk about that if you want to just, we still have water to go through too. I don't know if you want to just skip to that section, it's up to you.
Sure.
Well,
Okay.
yeah.
So, basically what I did is, obviously this is a gross analysis for the most part, but, the last two pages basically represent, some of the aspects that we'd be looking at. Potential grants, or low-interest funding. You have obviously the community compact, which we've already applied for $200,000 for a regional evaluation of wastewater alternatives. FEMA, you might be able to do some FEMA grants. In the past, we've done FEMA grants for system, flood proofing of a system. And certainly in terms of some of the sewer system aspects, we could look at that in terms of flood proofing, because some of them are subject to tidal fluctuation and storm flowage. State funding relative to some regional options. There is some grant funds that are kind of targeted, or zero-interest loans that may be targeted for regional options. Not too much as far as an individual community, but that's still a possibility. HUD does have some money for certain small communities that might be not a significant amount, but it's there. Obviously, there's funding through MWRA as well that can help. But those are the ones that come close to subsidized loans or grant types of situations. You can also look at the state revolving fund, which is a 2% loan. In some cases, you can extend the period out longer than the 20-year term. You can make 30-year terms, but SRF loans are a very effective way to implement both water and sewer upgrades in the system.
the grants would typically be in the hundreds of thousands and not millions.
Correct.
Safe to
Probably,
assume.
yeah,
Generally
probably.
speaking, yes.
If you add all these up, you're looking at 25
Divided
million.
by 351 cities and towns.
In terms of self-bonding or looking at the state revolving fund, the state revolving fund can be a very affordable mechanism. They typically 20-year terms, but we have done 30-year terms in the past. Depends on the administration. And for the most part, the only limitations on that is typically you would need a comprehensive wastewater management plan done for the community. This document that we have doesn't really meet that full criteria, so we may have to do some additional planning in order to qualify for those. But at a minimum, I would say we could work towards that. Every summer, basically August, you can basically do a project evaluation form submission and try to get on the intended use plan for the following year. So I'd say as soon as, fiscal year, the end of fiscal year 19, maybe fiscal year 20 essentially, you could be on the list for SRF funds in the millions of dollars, and that might help. They are loans. They are loans. 2% is the typical interest rate. And then obviously local bonding. The only limitations on that, and you'd have to check with bond counsel, is some improvements or repairs may have a shorter term that you have to carry them on. So the cost impacts of self-bonding may be a little bit higher than trying to group them all in together with an SRF loan.
Okay, so essentially, we're looking at borrowing most of the money anyway, over a term. And if anybody out in the audience wants to ask questions, by all means.
Even in terms of the SRF loans, I'm sorry, was there someone? I missed it.
Mr. Rower?
Okay.
Just a question, you probably considered it, but let me just throw it out to make sure it hasn't been overlooked. This is with regard to the routing of the drilling for the sewer. I noticed that the drilling picks up at the north end of the causeway.
I can't hear him.
Yeah,
Project-
Mike, why don't you?
He's got to come up to the...
Come on up to the microphone.
Thank you, Pedro.
The project seems to contemplate renewing the discharge pipeline along the causeway at some considerable cost. So I'm wondering whether there is the possibility to essentially do the directional drilling from the south end of the causeway and bypass the replacement of the pipeline along the causeway, whether that's more cost effective.
Yeah, we did look at that. Gil, you want to talk to that, or?
So you're talking about over near the old drugstore?
Yeah, I mean, there are limitations on the length of the directional drill that we can do from a technology base, given current technologies relative to that. There's a analysis that we went through basically to look at the stress induced on the pipeline to make sure that it can go that distance. And it's actually a longer length from that area, and that's basically meeting, it's actually beyond the thresholds of what current directional drill pipelines have extended using that.
So in other words, the limiting factor is how long a run of pipe you can pull through the hole after it's been drilled?
Yes, primarily.
Okay. And the distance, the longer distance, I take it, flirts with exceeding the limit, that limit?
It does exceed it.
Okay.
Yeah, although we were able to contact several drillers who were willing to try, but that's not the type of program we like to put together.
The basic answer, though, it's a longer run,
Yes, it's a longer run.
so that would be more money.
It would, at
Or
a
more
minimum, it would be
potential
more money,
problems.
but it also may be more prone to failure.
Yeah, okay.
In other words, you could try drilling the hole, you could drill the hole, but you couldn't find a pipeline to pull back through that had enough strength to resist it.
Gotcha.
Or it would impact the pipeline, so that it didn't have as long a useful life.
So you guys have looked at all these options anyway?
Right.
We did.
Can you speak for a moment to the repairability and maintainability of the shorter run that we're talking about, well, any run that's done with this technology? Once the thing's down there,
Right.
if something happens, what do you do?
Well, the question is, what would happen? How would the pipeline be impacted? The borehole is fairly deep below the dredge areas, so you're certainly not going to dredge it. The only potential is someone could drill into it. And if that were the case, then you'd have to shut down the pipeline, go in there and try to make a repair from the interior of it. But you'd have to shut down the pipeline to do that. The pipeline itself is fairly inert material. The HDPE will last a long time. In that type of environment, it's not being disturbed. You get more abrasion from the material inside the pipe than you would from any exterior. But it has a very smooth lining, and basically, so long as you maintain the proper, pitch and tilt and bends on the pipeline, it would not be susceptible to any blockage or accumulation of solids. That would be the only thing that, you'd want to make sure that you operate the system under a certain criteria, to make sure that it's currently flushed and continuously cleaned. But, there isn't much that goes wrong with that type of pipeline, short of a major earthquake or something drilling into it.
And Dan, has this type of technology been used for a good number of years, like
It
the
has.
HDPE with the pullback?
Yes.
Okay.
Yep.
And as you said, it's a 100-year pipe, potentially.
Yes. Right, and the pipe that we use is also a much thicker wall than what you'd normally see for an HDPE pipe. I mean, we're talking about, that is the wall thickness of the pipeline, essentially, so it's a significant pipe.
Do you know what the technology was, Marblehead, that was just used several years ago? What type pipe? Marblehead,
Marblehead
something
used
similar to
that.
this, their Salem.
Yeah,
Southeast Essex.
they actually dropped their pipe in place,
Okay.
They dropped their pipe in place?
yeah.
So,
Basically, they ballasted it and dropped it into place and rested it on the bottom.
That's not possible.
You have navigational channels that you have to,
It's too shallow.
right.
What happens to the old pipe that we currently have? Is that our new backup? And then do we need the
That's the intent, is basically if you do have this other pipe in place, or even if you do the interconnection with Swampscott on a temporary base, it will then give you an opportunity to evaluate the other pipeline more fully, to check the wall thicknesses, to check it for, using different technologies, basically to find out what the condition of the overall pipe is. And it may be that you have, 5 or 6 areas that you have to go back in and replace or repair, and then you'd have a feasible option. So it's something that's still worth looking into. You have your interconnection with Swampscott, and if that is in place, we have it starred twice because it gives you some advantages. You can then look and evaluate the rest of that pipeline and make a judgment. Is it worth saving? Is it worth continuing with? Is it worth going in there and trying to repair? Because repairs will be expensive, Or is the integrity of the pipeline wall so pitted and else that it really doesn't provide a long-term reliable solution? In that case, it could still supply an emergency solution to you. Or in the case of having, Swampscott and Nahant on the same pipeline, it would give another option for those peak max day flow periods, to handle the flow from both communities. So there's a lot of options, there's a lot of things in play that could still work and save the town money in the overall.
Real world in layman's terms, what's the preferred plan for, say, the next 10 years?
This is the baseline for that. In terms of the pipeline,
Yeah, can you describe just,
yep. This doesn't include the pipeline. Are you referring just to the pipeline?
yeah, with all the new information?
Okay.
This,
Yeah.
if you were us,
Yep. In terms of the pipeline, what I would do is I would try to push for that interconnection with Swampscott. Once that interconnection is placed, you can have a time shutdown so you can evaluate your pipeline. I would then evaluate that pipeline along the Linway,
this pipeline is the existing pipeline that's now.
on the Linway, correct. Then I'd evaluate that, and then you'd make a judgment whether or not you can continue with that pipe with repairs or replacement of sections, or if it's not feasible to do that in the long term. You could then switch back, use it for a period of time, and then concentrate on your other alternative, which is the Cross Harbor pipeline. But you want to probably also work simultaneously with that. If you do get the grant funding, that money is to evaluate that pipeline. It's a long-term process, a long-term permitting process. You don't want to lose too much time, waiting to evaluation of the other pipeline after you construct an interconnection. So you really want to go on the same track for both of those if you can. But at that point in time, after you evaluate the Lynn pipeline, you can then, or the Linway pipeline, I should say, at that point in time, you can then make a decision to go which route you're going to. And that's the primary focus. In terms of in town, this would still be valid for everything short of the pipeline options, okay? I don't feel that the Causeway pipeline is in dire need at this point in time. The history's been pretty good. We do have to do some maintenance on some of the air release valves so that we don't have pipe corrosion. So I'm still feeling that some of those air release valves that we have in the system are still valid for repairs, and we need to try to address that in the long term, or the short term, I should say. Those recently corroded off. The reason they corroded off is because of sulfides in the pipeline. If you no longer have those air releases there working and functioning, it's going to start attacking your pipeline and it accelerate, maybe more problems for you. So there's a couple of things that we still need to address on the overall pipeline length, but I think the Causeway could probably stay in place for a period of time. The replacement of the Causeway pipe, I think we could try to slide off as long as possible, in order to get it in a more manageable position as far as expenditures and borrowing.
Is it possible to get a recommendation of this, say 15.8 million on the sewer side? What year one, an ideal scenario, because I'm assuming that some of these costs are going to be front-loaded, and then it'll taper as we're on more of a maintenance versus a repair schedule, so that we can see sort of where and how we're going to have to spend this money and how we're going to have to figure out how to carry that down.
Yeah, I mean, the next step for us is to update this table, essentially.
Right.
Basically, you started out by saying that there are interferences in Linway with our pipe.
Well, not interferences with our existing pipe. There are interferences in trying to replace that pipe.
You said that there's things that, electrical interferences, things
Oh.
that create extreme
Correct.
that's required.
Yes.
Is there cost recovery based on that, and that we relate our pipe, but there's things that interfere with our pipe?
Very difficult to pinpoint that. Yeah, it would be
Maybe
very,
we're the only ones that have that problem, unless we're the only ones who have that kind of pipe along that space.
we tend to be, except for maybe a water main or two that are in the roadways. But, we are also diving underneath culverts, and some of those are in the water table. So you have multiple things that are attacking the pipe. Even though it looks to us, based upon the nature of the repair, that it was basically electrolysis of the pipe,
Right, so is there,
it's hard to say where that power is emanating from. Is it coming from the duct bank? Is it coming from straight currents, running along another pipe? Is it coming from rectifying equipment? It's something that, at this point in time, you don't.
it's not cost effective to go down that route for cost recovery?
No, it'd be very difficult to prove any type of litigation if you're looking for some type of cost recovery.
I think we tried
That was
on
looked
the,
at,
on the
that was
first
looked
one.
at by us. The cost recovery was looked at.
Right, and I think we did try to,
Right, through.
the
actually
first
through
one,
you.
on the first, because it was supposed to be a catch basin on top of it, but,
We're still pursuing that.
yeah,
Oh, we're still pursuing it, says Dennis.
Yeah, you don't give up.
deniability.
So Dan, speaking to the Linway and the fact that we made some observations on the Swampscott pipeline and how it touches it at times, but I'm curious, and they've had no water main breaks on the Swampscott side recently, is it more an effect of kind of their pipe design, or the fact that they're not going under these culverts and things like that on their way
They're 10
to?
years younger than we are.
What's that?
They're 10 years younger than we are at this point.
But is their system technology similar to what we have?
The pipeline
Their
technology is very similar.
Very similar.
Okay, they run along you know, the Linway for a section, but then they go up across town, and that's all elevated above the groundwater table, better soils, no groundwater fluctuations, and less electrical components in there.
Okay.
Less vibration from vehicle traffic.
Sure, a lot of traffic.
41,000 cars a day.
The Swampscott is the corner of Nahant Street and Lakeshore Drive. They then take a right turn up Nahant Street, and they meander from Sagamore Hill, end up on Broad Street, and then they run out down the Linway on the opposite side.
So it sounds like,
The other curve.
it sounds like proximity.
They're not in that maze of utilities that we are in.
Well, like I said earlier,
Say that then, is there any value in running space from Swampscott, that's how it's done, following the same path?
I mean, it is a feasible option as far as running it that way, but it's also a lot longer, and it's also land construction. And the land construction that we found was basically more costly than what we had with the directional drill.
Have to dig up the streets.
I think we're eliminating how many miles of pipe by going across the harbor?
I'm not sure if it's
Not much.
Not miles, but I mean, if,
it's a good distance, though.
yeah. I mean, I think that's the way to go. I mean, I would really,
You'd actually be making it longer going the other route, but.
very supportive of going across the harbor.
And, you know, even from that perspective, if we tried going up that hill and back down, there's a lot more head conditions that we don't have on our pumps. And that may end up driving us to changing out our pumps, increasing the horsepowers, and now you're doing major construction on the pumping station as well.
Any chance we could just look into Swampscott and pay them?
I don't, see, the problem is, they utilize that full capacity of their pipeline during their peak flow events. So a long-term tie-in for them, I think, would be problematic. I don't think they could justify it to their users.
So on the water side, there's also significant expenditures that we haven't touch on the water side.
Sure. So anyways, again, color coding, the black is on this sheet as far as the spreadsheet from the March update of the capital plan. We also have some additional items in here. And again, we've added these, the brown ones, for a couple different reasons. One is looking at that break, the recent break, there was a lot of exterior corrosion on that pipeline, a lot of pitting. It wasn't electrolysis so much, it was more brackish water, groundwater table fluctuation, and possibly soils. And you have a lot of water main that are in that type of zone within the community, within that fluctuating area of groundwater tables, and also with similar soil conditions. So what we're really looking at is potentially some evaluation of the wall thickness, and those types of evaluations are very similar to the ones that you do on the sewer force main, basically with probes measuring the wall thickness on some of these pipes. So we can do that. There's old techniques like doing coupons and stuff like that on the pipeline. They would actually take a core out of the pipe, but those tend to be destructive to the pipe over a period of time. We do have two main feeds coming in, so we do have a lot more flexibility in evaluation of the pipelines than we do with the wastewater force main. So for the most part, we've added in some dollar values in here, assuming that we do have some similar conditions in other areas of the town. We have $200,000 basically for evaluation of the pipelines. And then if you jump down one other item, replace deteriorated mains, the results of that evaluation would give you an indication of what mains need replacing. We also have some cleaning and lining of some of the older mains. We suspect that because of the age of some of the pipes, the interior linings are gone, and that then accelerates the corrosion and potential for the pipeline to break. So those two methods that you have there are basically rehabilitations for some of your larger mains. And although those could probably be slid for a period of time or a series of years because they're not known at this point in time. I did want to include them here because there's a high likelihood that you do have some of the other issues here, and in order to plan it correctly, I'm adding those in as dollar amounts for future years. One more time. Oh, these are all over the place in terms of age. Chief,
We were pretty proactive back when Mark was in,
Yeah,
doing a lot of water main work.
there's a lot of, there still is.
Mark did a lot of water.
You know, water main replacement is still being conducted on a regular basis. You get funds on an annual basis to do main replacements. You do have a lot of small mains, and if you look at some of the black items, you have 4-inch and 6-inch mains. Those are very hard to maintain. The 4-inch are very susceptible to clogging and reducing of hydraulic capacity. One of the things we did when we did the large report was we created a network model of the town's water system and then evaluated in terms of pressure conditions and flow conditions to make sure that we had sufficient fire flows in certain areas and what the restricting factors were. And then we ID'd those mains that would need upgrading and replacement in order to provide adequate fire protection in certain areas. So a lot of these 4 and 6-inch mains that we have here targeted for replacement are a result of that study because they, again, provide poor service and poor hydraulics within the system.
We say, I'm looking at replace deteriorated mains for $2 million plus. Can they use plastic now?
Oh, certainly.
Okay, so are we using plastic as we go along, replacing?
The last 2 we did not, we used ductile.
Yeah, I mean, ductile is still a reliable solution, so long as it's maintained, and nowadays you do have good epoxy coatings. If you're in a groundwater fluctuation area, you do the poly jackets as added support. You know, and ductile has its ability to take pressure surges and you know, when you're opening hydrants and closing valves, which you do on a regular basis. You don't do that so much on the sewer system, but you do it on a regular basis on the water system. Those types of water hammer effects or surge waves that are generated when you do that type of work stress the pipe. So ductile is still a good alternative in terms of, you know, being able to maintain that. You can use, you know, they call it, you know, brand name is a Blue Brute. It's a thicker wall PVC pipe, but you know, you have the potential for a large surge wave could basically rupture a pipe and have a break.
Do you have any understanding of how old our oldest pipes are?
Yeah, you know, it's been a while since I looked at the plan. We do have you obviously have a GIS system that we use a lot, and we do have some ages on those pipes. But I mean, you have pipes that are, you know, easily 100 years old, I think, still in the system, so.
And what's the average lifespan for?
Well, again, we usually try to look at it in terms of, you know, 60 years is the typical thing. But in reality, you know, you look all over the state, you have old pit cast iron pipes that are still in operation in a lot of communities, and they're 200 years old almost, you know. Not very good, but.
Are there water quality issues with those older homes?
The town's been very lucky in that regards. Their water quality has been very good throughout the system. You maintain good residuals, you don't have any poor conditions, generally speaking, so,
We test the system twice every 2 weeks.
yeah, I mean, the system's been very good in that regards. It's a good quality water overall.
And I noticed that Dennis at the very beginning mentioned pipe depth a lot. I mean, when we talk about replacement of mains and things like that in pipes, I mean, are our pipes kind of, are they at best practice depths, or, I mean, there's opportunities, we were talking about salt water and stuff in
Yeah.
terms of pitting, and, I mean, are there opportunities to kind of move that depth to kind of, so that in terms of just future?
Yeah, you typically like to have them below frost depth, just so you don't have that force acting on the pipe so much. And also, so nothing freezes, obviously. In certain areas, I mean, we normally assume, you know, 4 to 4.5 feet is a typical frost depth. A lot of water systems will place their pipes 5 feet down, 5 feet of cover. that may place it in the groundwater table, you know? And, you know, that can add to construction costs, but it also can add to, you know, issues with deterioration of the pipeline. You actually get more deterioration if it's in that area that gets wet and dry on a recurring base. You know, if you're deep in the groundwater table, it's probably less likely, but, you know, you have less corrosion. But generally speaking, you like to keep it below the frost level. And I should mention, you know, sometimes we've done pipelines along the ocean, and the frost depths can get pretty deep sometimes in some of these areas that you wouldn't suspect, because the, you know, when you have water that's close by, it basically reduces any geothermal heat that's coming up from the earth to make the frost depths go down even deeper. So we got to be careful of that to some degree too.
Okay. Well, Mr. Chairman, that's enough information, I would think.
Okay. Well, I think it was a good
Excellent,
way
sir.
to get people
Thank you.
ready for town meeting, because I think we're gonna have to do some funding. I mean,
So if we task Dan with kind of making updates to this.
oh, yeah,
information.
you'll be making, yeah,
Yeah, it's already planned.
yeah, absolutely.
So, Mr. Chair,
We just summarize what the total anticipated cost of the water is and what the combined is for the
Yeah,
benefit of those that haven't seen the,
If you look at that,
we're also on television, and folks at home probably don't have that in front of them.
the wastewater total that we project, and this is over a 10-year period again that we're looking at, these expenditures, is about $15.8 million. And the water end is $12.2 or $12.3 million, for a total of about $28 million over a 10-year period. So that's about, if you want to look at it on a yearly basis, it's about 2.8 million. We did provide on the very last page kind of a very gross analysis of what those potential impacts could be.
A lot of this is 50 or more years life
Expectancy for the new facilities.
stuff, so you could reasonably go for very long-term budget.
No, according
No.
to Deb's
No.
analysis, the max we can do is 30 years.
30's not bad.
Okay.
I'm with you.
Yeah.
30's good.
That's Deb's analysis right there.
So, I mean, in terms of, sorry,
The net is 28.2
Right.
cash expenditure over 10 years, or
current dollar.
likely be
Yeah.
able to borrow over a 30-year term to cover.
Correct.
Good point.
Should at least have something prepared for the annual town meeting, some of it, anyway.
Well, I would assume that this would be worked into the budget, especially if we anticipate borrowing anything for FY
Right,
19.
19.
Yeah.
And assuming that we're gonna have to front load it, I don't know that we're going to fall under the average of the 2.8 million. So we're gonna look, I'm assuming, to borrow significantly more than that. We'll have to figure in the carrying cost of that debt
Right.
into the budget. And I'm sure when you set the water and sewer rates, that'll get impacted in there, as well as the debt shift and the total debt load for the tax rate.
Okay. I hope this gave people the perspective of what we're up against, and that we need to get it done. So that was, you know, the whole idea behind this meeting, and I think it was pretty good, even though
Sure.
some of the...
We'll update this table.
done.
That will help a
Yeah.
lot.
Time frame on that?
It shouldn't be too long, probably sometime next week, actually.
Okay.
All right, good. If you guys want to talk, absolutely, why don't you stand, just come up to the microphone, though, so we can...
Give your name, please.
David Elmer, 215 Nahant Road.
Thank you.
Thanks very much. That was a great presentation. My question was related to the 314 CMR report, CMR 12, the II control plan report. What kind of commitments have we made as far as the investigation and rehabilitation of the collection system assets?
Well, even prior to the regulations coming out, I mean, they've been working on those regulations for years. They came out in May, which was actually too late to actually implement them this year, but still required everybody to implement them. So I think every community at this point in time, unless they did it in advance, is looking for an extension. And that's essentially what we'd be doing as well, outlining what we've done in the past and also putting in an extension of time. Now, the commitment on there is, the state has formulated a standard guideline. It's very similar to the one they had before on how to do these types of evaluations. A lot of their evaluations start off with flow monitoring and doing different system inspections. For the most part, when we did our 2015 report, we looked at flows from the pump station perspective. Not exactly the ideal situation that DEP would like, but from terms of a cost perspective, it was very effective in identifying where those reaches were that had high II, and also gave us an opportunity to take the next step, which is kind of an advanced step in their program, and that's to do the CCTV inspection. I've always found that doing the in-pipe inspections can yield a lot quicker, better results and give you guidelines as far as, or give you knowledge as far as how to do those repairs more quickly. And that's the program that we've put in place and had in place for a couple of years now, is doing that CCTV inspection. Like I said, we're about 3/4 or 2/3 of the way through phase one. We had a 3-phase program set up in place. We still have a lot of the system to inspect and review, but just in the ones we've done so far, we've been able to identify a lot of problems and issues, and that's what's reflective in this summary sheet as well. But in terms of compliance with DEP, I mean, DEP has their general guidelines, but they are always open to alternatives that work best for a community. And in our view, this has worked very effectively for Nahant in a cost-effective manner. Instead of spending $300,000 or $400,000 on flow analysis, we're using the pump station data. We're analyzing that data under different scenarios, because we do have daily data. And again, doing the CCTV inspection, which should accelerate the town's overall program.
Thank you very much. I'm glad to hear that you took that approach. That's absolutely the right thing to do. I'm glad to see that we didn't spend that money on flow monitoring. It's not the right approach for a community our size. I agree 100%. Thank you.
Sure. Did you want to ask something, Chet? All right.
Just, Dennis, thank you. And
Yeah.
to you and Dan for all of this work. I know that, you sort of walked into quite a scenario, and I don't think have had a break since you got here. And putting this together and sort of taking a look at the report that Dan has created and conferencing with Dan and being able to present this is greatly appreciated.
I agree. Dennis has done a great job since he's been on.
I agree as well.
Hasn't even been a year, has it?
One long year.
10 years.
He has a little whiter.
It's Italian blonde,
Thanks, Dan. And I really appreciate the FinCom coming, and it's nice that we can all sit down and talk about this before town meeting, again, so that, I mean, you go to town meeting, everything's ready, everything's prepared, and people get 5 minutes to make a decision. This way here, they can, if they're watching, or if some people came, they can get a sense of what we're really up against and what we need to do, so they can make an informed decision when it comes to that day.
So, Mr. Chairman,
Yes.
how would you like to present this information to the general public? I mean, this is presented primarily...
We can give these handouts to people.
Well, this is essentially a PowerPoint.
Yeah, this is perfect, because, I was looking at that book, and I know Frank McCardle out there, he has one of these books too, because he was on the, actually, we did a lot of analysis. It was Frank and you and Mark, and I showed up to a couple of meetings, and that book is just way too big. But it's very informative. And if you look at it, it gives analysis from people like Timmy Lowe. Sure. You questioned all these people, what do you think we need to do next? And where all the problems are, and it's pretty detailed, but this is great, this PowerPoint. We could probably have some of these available.
So what would you prefer? Would you prefer this document, or would you prefer the spreadsheet available on?
I think this is fine, don't you, T?
I'd like to see the spreadsheet, once it's
Spreadsheet?
updated.
Okay.
Once it's updated.
All right.
It's a little bit more informative.
Yeah.
All right.
And
Maybe
people
we
can
do
see, see out.
We can put one,
That's your call,
yeah,
yeah.
we can do both.
To address the question to, but what is the, not the technical plan, but the management and political plan going forward?
Well, we're gonna go after Brendan and Crichton tomorrow night. That's the political plan.
I think we have to see how the budget
Yeah.
presents itself.
Yeah.
And how the department submits the budget, the Department of Public Works submits both their water and sewer budget and their long-term capital plan budget. And then when the selectmen send us their budget, we'll take a look at that, and there'll be continued hearings on this through the budget
Yeah.
process, as there always are. But I think, it will work itself out through the budgeting process, I think is the answer to your
Right,
Right.
right,
And
that's what we hope.
how much of a bite do we wanna take out of this, right
Right,
off the
and
bat?
what, I think this updated spreadsheet is the answer. That's the first step.
'Cause the
And
longer-
we all will have it too, so we can all,
We'd be remiss if we didn't point out that one of the things that the finance committee has thrown red flags up for the last several years is the reliance of the town on borrowing for short-term needs and non-capital projects.
Right.
As the massive scope of the capital projects that are coming down the line, we would urge the selectmen as a finance committee to show some restraint in the need for borrowing for non-capital items such as vehicles and other things that have seemed to have been thrown into the borrowing that we have to pay to carry for long periods of time. So with this, hopefully that will give some incentive to that conversation of how do we wean ourselves back to paying for things that have short lifespans out of, so to speak, cash.
right.
Right.
As opposed to borrowing.
It should be in their budgets, most of these things. I understand that. I think that, like I said, little bites. I mean, if we keep waiting, it's gonna be one huge big bite. And it's gonna just,
But that's, we'll work that out.
yeah.
The selectmen will work that out.
Brendan's gonna
and
write us a
we'll
check.
Work it out with them. Brendan,
Not me.
not this Brendan.
I thought it was you. All right. No, I really appreciate you guys for coming. And the Finance Committee does an awful lot of work, and people really need to appreciate them because I go to their meetings, and let me tell you, it's pretty grueling. I see these guys here till 11 o'clock at night during budget season. And budget season has started, really. I mean, we're in it, the thick of it now, and starting it anyway. And they do an awful lot of work, and I congratulate them for what they do because it's a volunteer job, and look, they put it together, so thank you. And thanks for coming.
Do we have any other business, Mr. Chairman? Has
No.
the board here?
Motion to adjourn? Do I have a
So
motion?
moved.
Okay, I'll second it. Pedro, we're done.
All in favor, aye.
Aye.